Good day everyone, here's our math challenge for today. And here's our question. Simplify the expression cube root of 2 minus 1. Now, if you want to try this question, you can pause this video anytime you want. So you can try it first, and if you get the answer, then please consider this suggested solution. By the way, this question is also known as the Ramanujan's nested radicals. Now the question is, what is a nested radical? Now in algebra, a nested radical is a radical expression that contains another radical expression, like cube root of 2 minus 1. And our goal in this question is to denest this radical expression. Now, what is denest or denesting? Some nested radicals can be rewritten in the form that is not nested, and rewriting a nested radical in this way is called denesting. This is not always possible, and even when possible, it is often difficult. And that's our goal in this video, to denest this cube root of 2 minus 1. Now, let's start our solution. Now, to answer this question, first thing to do is we need to have a plan, of course. Now, here's our plan. If we have cube root of something raised to 3, then cube root and cube cancel out. In that way, we can say that we already denest this radical expression. Now, at this point, let's focus on the expression cube root of 2 minus 1. Now, one thing to notice is we have a subtraction sign. Therefore, maybe we can use this identity x cubed minus y cubed equals x minus y times x squared plus xy plus y squared. Now, at this point, x must be cube root of 2 and y must be 1. Now, let's multiply this expression inside the cube root by cube root of 2 raised to 2 plus cube root of 2 plus 1 squared. Now, if we do that, the numerator of this fraction is equivalent to x cubed minus y cubed, or simply cube root of 2 cubed minus 1 cubed. And cube root of 2 cubed is just 2, so we have 2 minus 1. And 2 minus 1, very simple, this is just 1. Now, let's simplify. 1 squared is just 1. Now, at this point, literally, I stuck. But, through the help of our plan, again, our plan is if we have cube root of something that is cube, or the inside part is raised to 3, then we're done. So, maybe we can use this identity x plus y raised to 3 equals x cubed plus 3x squared y plus 3xy squared plus y cubed. And now, our problem is we have 4 terms, but on the denominator, we only have 3 terms. Also, the middle terms have a factor of 3, but in the denominator, we don't have a factor of 3. But this is easy to do, so just multiply the numerator and the denominator by 3. So let's multiply the inside expression by 3 over 3, or just 1. Now, if we do that, we get 3 over 3 times cube root of 2 squared plus 3 times cube root of 2 plus 3. Now, here's the trick. This 3 can be written as 2 plus 1. Because we know y equals 1. So we can use this 1 as 1 cubed, still 1. And this 2, we can put this in the front. And take note that this 2 can be written as cube root of 2 raised to 3. Now, we have 4 terms on the denominator. And this is somewhat related to this x cubed plus 3x squared y plus 3xy squared plus y cubed. If we replace x equals cube root of 2 and y equals 1, we get this expression. Therefore, the denominator of this fraction can be simplified to x plus y cubed, or simply cube root of 2 plus 1 raised to 3. Now at this point, we now have 1 cube inside this cube root. Now this 3, take note that this 3 can be written as cube root of 3 raised to 3. Now let's recall some laws of exponent. If we have a raised to n over b raised to n, it is equivalent to a over b raised to the power of n. Therefore, the expression inside of this cube root can be written as cube root of 3 over cube root of 2 plus 1, all raised to the power of 3. Now take note that this is our plan. So we have cube root of something raised to 3. Therefore, this expression now is equivalent to something, or simply cube root of 3 over cube root of 2 plus 1. Now, what we're going to do now is to rationalize the denominator. Now, in order to do that, we will use this identity. If we have x cubed plus y cubed, it is equivalent to x plus y times x squared minus xy plus y squared. Again, in our expression, x must be cube root of 2 and y must be equal to 1. So, let's multiply this expression by cube root of 2 squared minus cube root of 2 plus 1. This is just x squared minus xy plus y squared. Therefore, the denominator of our fraction can be written as x cubed plus y cubed, or simply cube root of 2 cubed plus 1 cubed. Now, cube root of 2 cubed is just 2 and 1 cubed is just 1. So, 2 plus 1 is just 3. Now, let's simplify some terms. Cube root of 2 raised to 2 can be written as cube root of 4. Now, we can distribute this cube root of 3 to the rest of this expression, and we get cube root of 12 minus cube root of 6 plus cube root of 3. Therefore, one equivalent of cube root of 2 minus 1 is 1/3 times cube root of 12 minus cube root of 6 plus cube root of 3. Now, using this result, we can manipulate this and get that cube root of 2 minus 1 is also equivalent to cube root of 4 minus cube root of 2 plus 1 all over cube root of 9. And again, if we manipulate this, if we divide all terms by cube root of 9, we get that cube root of 2 minus 1 is also equivalent to cube root of 4 over 9 minus cube root of 2 over 9 plus cube root of 1 over 9. Therefore, we get 3 equivalent of cube root of 2 minus 1. And there you have it. We have 1/3 times cube root of 12 minus cube root of 6 plus cube root of 3, or cube root of 4 minus cube root of 2 plus 1 over cube root of 9, or cube root of 4 over 9 minus cube root of 2 over 9 plus cube root of 1 over 9. And as always, we are done.